For this question, you need a common denominator. So we're going to use 2x plus 3 and x plus 3. Multiply every single part by those. So I'm going to have x plus 3, 2x plus 3 here, x plus 3, 2x plus 3 there, and multiply the 1 by x plus 3, 2x plus 3. So doing that, the 2x plus 3's here are going to cancel out, and it leaves me x times x plus 3. Over here, the x plus 3 is going to cancel out, and it leaves me a minus sign because of that minus. Now it's going to be 2x plus 3 times the quantity then, x plus 7. Equals then 1 times x plus 3 times 2x plus 3. The key thing to remember here is that this minus sign is going to affect this entire trinomial once we multiply it all out. So it's going to be x squared plus 3x. I'm going to leave the minus sign right now, and I'll just multiply out that trinomial. 2x times x is 2x squared. 3x and 14x gives me 17x. And then 3 times 7 gives me 21. Equals in over here 2x squared, 6x, and 3x gives me 9x, and then plus 9. So here's where the minus sign really comes into play, is that it's going to be distributed to the 2x squared, the 17x, and the 21. A lot of people just want to distribute that to the 2x squared and then be done with it, and that messes everything up. Combining like terms on the left-hand side, I get negative x squared, negative 14x minus 21, 2x squared plus 9x plus 9 on the right. Flip everything over. I'll get 0 here. This will become a 3x squared plus 23x, and then plus 30. I'm going to go the a times c method. So 3 times 30 will give me 90. Two numbers that multiply together give me 90, and apt to give me 23 or 18 and 5. So it's going to go 3x squared plus 18x, and then plus 5x plus 30, where this 18x and this 5x come together to make that 23x. In the first grouping, take a 3x out, gives me x plus 6. In the back, I take out a 5, leaves me x plus 6. So now I've got 3x plus 5 as a factor, x plus 6 as a factor, and now solving that, x will equal negative 5/3, and x will equal negative 6. Once I'm done with these, I'm going to go back up to the beginning to make sure that I don't have an issue with them. So negative 5/3 and negative 6 for the answers. Looking back at the original problem, if I plug either of those in to that denominator, I do not get a 0, so it's okay. And the same thing happens here. If I plug either of those in, it's okay. So both these end up being solutions. If for some reason a problem arose where I would get maybe, and for this problem, a negative 3 as an x, well, then I would have to cancel that out because I get 0 on the bottom and cannot divide by 0. This question, we have to isolate that portion first to end up being able to square things. If I square them right away, I'll never get rid of that radical. So what I'm going to do is I'm actually going to move the 13 to the left-hand side and the radical x part to the right-hand side all in one step. So it becomes x minus 13 is equal to then radical x minus 1. The reason I do that is I want that radical to be positive. You don't have to, it's just a preference. Now we square things. Square that, square that. So squaring the left-hand side gives me x squared minus 26x plus 169. The right-hand side now gives me x minus 1. I'll subtract x from both sides to get x squared minus 27x, add the 1, so plus 170. is equal to 0. Okay. Now I'm looking for two numbers that multiply to give me 170 and add to give me negative 27. So those two numbers are negative 10 and negative 17. So again, x is equal to 10 and x is equal to 17. Now, because I had a square root function, I've got to make sure that both those work. I will have most likely extraneous solutions because of this squaring procedure. So what we're going to do is we're going to plug in the 10. So I'll plug in 10 here. I get 10 minus 1, which is 9. So I get 10 minus the square root of 9, which is 3. So I get 10 minus 3 is equal to 13. And that obviously is a false statement. 7 does not equal 13. So 10 does not work. So that probably leaves insight that 17 is going to be my only answer. If I plug 17 in, 17 minus 1 equals 13. So I get 17 minus radical 16, and that's 4. So 17 minus 4 does equal 13. That's a true statement. So 17 is my only answer. Equation through these 2 points that we're looking for. Before you do anything, just pay attention to the ordered pairs. If they have the same x value or the same y value, graphically they should be pretty easy to deal with. I have x is 5, 4, so let's just say 5 and 4 there. So that's 5, that's 4. So I got that point there. And then 8, 4 would be maybe there, and there's 4 again. So that becomes a horizontal line. Well, horizontal lines are in the form of y equals, and then whatever value they cross through on the y-axis. So in this case, y equals 4. Okay, so much easier to do it that way than to do slope and all that kind of stuff. You can find out slope here to be 0, plug in the y minus y1 equals m times x minus x1. You'll still get y equals 4, but that's just a little bit more efficient. This problem here is trying to use that formula, y minus y1 equals m times x minus x1. We need the slope, so negative 2, 4, and negative 1, negative 4. The slope, remember, is y2 minus y1 over x2 minus x1. So I'm just going to subtract my y's. So I go 4 minus negative 4. And then I'll subtract my x's, negative 2 minus negative 1. So 4 minus negative 4 gives me 8. Negative 2 plus 1 gives me negative 1. So my slope then is negative 8. So that's my m value here. Okay. Now my y1 and my x1 come from these points. Doesn't matter which one you use, I'm going to use that one. So minus a negative 4 would become plus 4. And now minus a negative 1 would become plus 1 there. So we get y plus 4 equals negative 8x minus 8. I'll subtract 4 from both sides to get y equals negative 8x minus 12. And there's my equation. You must know that formula and that formula to be able to do these and to be successful in the final.